Welcome to our Bucky call for the weekend of 9697, before a couple of birthdays this week. So Fred's having his birthday this week. Richard's having his birthday this week. Um, and Joe is handling family situations with his mom passing this last week. And um, our hearts are with you, Joe. So, welcome to our Bucky call. We're going to be doing a fuller explanation. And we're starting off on page 189, and we're going to be starting off with four dimensions, the section on four dimensions. And I really must say that it's been really tough going these last little whiles, but to understand a little bit more about pi being two-dimensional and phi being three-dimensional was a big epiphany for me. Even though it may have been obvious to me, it really hit me. And we're going to go start looking into this four-dimensionality, and I'm very excited about that. So, Lee, how are you feeling tonight? What do you anticipate getting out of the call?
I can't get off.
You have to mute your phone if you unmute. Do you know how to do that?
Right.
All right, why don't we? You've been trying. All right, hang on one second, everybody. Tap it more purposefully. Don't tap it so quickly.
First off, Joe, I feel for you, but I am grateful that you have been such a great son.
Thank you.
And I've watched you.
Thank you.
God bless you.
Thank you. Thank you very
I
much.
feel wonderful. But I said earlier that I had no idea what happened to me last week. It was so confusing. And I'm hoping I can get some clarity in this week for what we learned last week. Richard, how do you feel? And how would you like to, what would you like to say, achieve?
Well, thank you. I'm feeling a lot of things right now. Certainly, my thoughts are with you, Joe, and your family, and
Yeah.
the time that you have with grieving and celebrating the life of your mother, and we had an experience this last week. When I say we, my wife and I, after quite a long time, our sister-in-law, who was in Australia for many years and died 2 or 3 years ago, and we did the final interment at a kind of a hometown cemetery along with her husband, my older brother. That happened last week, and our daughter, who has been on the road with her first novel, doing readings across northern British Columbia, ended up with an emergency gallbladder operation, which she came through successfully last Friday, and finally got home to southern BC on the weekend. So that was good. And on Thursday, I had one of a number of reunion dinners with 4 students, or 3 students, that I worked with back in the 1990s. 2 of them spent a practicum with the Hill Tribe people in northern Thailand, and one was in southern India, in the state of Kerala, and so when we get together, it's always lots of good memories and good times. And one, Rosalind, who was traveling for, it turned out, about 6 months, and Malaysia was just one of the places that she got to. but Malaysia was where she was born, and her family's Chinese Malaysian. So that was good too, to get caught up on all of her travels from to Malaysia and Singapore and Nepal and India, and my gosh, and she did all this on her own. And she's a woman of probably 50 years old now, with young children, adult children, who are now away at university and that sort of thing. So she was out exploring the world. And she felt sorry that she missed finding Yuan in Malaysia. And I said, well, I think you were probably in Canada at the time. But anyway, so it's a good feeling, and looking forward to the four-dimensionality. Fred, how are you feeling, and what's your expectation for today?
Thank you, Richard. I'm feeling pretty good. As I said when I entered the room, I broke fast, so I feel better than yesterday, which I spent waiting on the carpet because I had keto flu, not eating for 48 hours, not feeling good at all. But I feel good today, now that I've eaten. And that's about it. Richard, at some moment, I would like to know, I know you're a professor, but I would like to know what you were teaching. You can tell us after the intro, what do I do? What do I feel like saying?
Well, just briefly, I was teaching social work.
Social work. Is that okay? Okay, thank you. My expectation for today is to try to, little by little, get a better understanding of Bucky. That's my expectation. Anne, what do you feel like saying today? How do you feel, and what's your expectation?
It's always good to be in the meeting. I always look forward to it. So all good here. And Joe, good to see you. Yeah. And lovely to meet you, Fred. And I think we'll be able to get to know each other more. Yeah, during the call. Yes, I actually usually when I miss a meeting or I come back, and when we head towards the end of the chapter, usually all the big moments come around there. And so I'm really looking forward to this chapter to see, how it ends with our, this chapter. I like the title. It is on, Jitterbug. Yes, that's right, Jitterbug. Yeah. So I'm really looking forward to see how that ends, because every time we hit there, those big moments come. So yeah. And Joe, how do you feel, and what do you expect to take away today?
I'm feeling good to see everybody, and I appreciate everybody's well wishes and concerns. One of the things that actually really helped me through this process, and this is something that I've had a lifelong fear of, and something that was always I was going to find to be difficult, but I realized I have a lot of good friends, like everybody here, and that makes it a lot less difficult. And I think Wayne, actually, when the conversation with him last Monday, really, it's it's grief shared is halved, and joy shared is doubled. And so and I really feel like that. So so I'm very, very fortunate. My expectation for today, we're going to get into a lot of more about the Jitterbug and in complexity. So, as far as understanding it, different models, and how how essentially I'll just say that the complexity of the Jitterbug, because that's the part where we left off roughly. So I'll leave it there. Steve, how do you feel? What do you take it away from today?
Well, I'm feeling really good. I'm glad everybody's here. All my equipment seems to be working. The system seems to be going well. And I had a good vocal exercise before the call today, so my voice feels up to par. Um, and this has been a really challenging section here in this in our studies. I'm looking back on page 183 when this whole starts out. It says, because we are looking at the jitterbug, and it says the jitterbug exhibits total transformation of shape and size without any change in material. Nothing is added or taken away, but the system characteristics are profoundly altered by rearrangement of the parts.
Mm.
The concept is reminiscent of the differences between ice, water, water vapor, all consisting exclusively of H2O molecules, which is kind of interesting. And it says at the 0 point, 24 wooden dowels and 12 rubber connectors, representing the giant cube octahedron, embrace a volume of 20. As we recall from multiplication by division, after contracting and twisting through the jitterbug, the bundle of sticks encloses a single unit of volume, one tetrahedron. The system has gone through 20 tetrahedron volumes to one, with a stop at 4 at the octahedron. I'm still doing what I can to get my head around that, but as we head into 4 dimensions, I think that's helpful. What was very confusing with me last week, and it took me a while, was to read that the octahedron is within inside the icosahedron, but also to find out that the icosahedron is within the octahedron. That blew me away. These shapes are just all interrelatable. And to find out that the offset in the previous examples, when it goes down through the jitterbug and we go down through the tetrahedron into the, or from the cube octahedron down in through and get to the tetrahedron, that it's division by 2 usually. It's a V2 kind of thing. When the icosahedron appears inside the octahedron and vice versa, there's an offset. It's not a division by 2, it's an offset, and the offset is phi. Now, I'm still contemplating all that. If I got any of that wrong, please explain it to me. If you think I did not explain it exactly right, if Manu were here, I'm sure he would have something to say about it. But that's kind of the basis of my confusion. And now we're going to start in with 4 dimensions. Any other thoughts or musings before we start into the reading?
Yeah, I do, because one of the things that I probably have to struggle with in terms of moving into some of the way this 4-dimensionality is being explained is going back to my first real grip with 4-dimensionality through the Tetrascroll story and the graphic of the observer observing the Trinity, the 3 bears, the Goldilocks and the 3 bears, and really showing how that Trinity in a 3-dimensional sense, the X, Y, Z understanding of 3-dimensionality that we all have, or at least I have, and that the observer, according to Fuller, in that context, became the 4th dimension, and that you couldn't connect the observer to the observed through a 90-degree angle system. You had to change it into a 60-degree angle system, and then they all came together. And so my basic understanding right now of 4-dimensionality is observer plus 3-dimensional observation equals minimum 4-dimensionality in all situations. So I think some of this is trying to take me not beyond, but in addition to the current understanding of 4-dimensionality for me into perhaps a new and expanded understanding of 4-dimensionality. So that's my baseline, and so that's will be part of my challenge as we go through this particular part of the reading.
Cool. Anybody else have any observations, queries, deliberations, inhibitions? Okay. All right.
I have something to
Okay.
point out. Because when we started going down this path of dimensions, and I was talking to my team, right? And I said, how many dimensions have we discovered to this point? I'm gonna check back again as to how many, but it wasn't at 4. It's like if I'm not wrong, is it 7?
In quantum mechanics, they say between 10 to 11 are
Oh, there
mathematically
you go.
proven viable. That's what
Mm.
they say.
Yeah,
But they're just
and
very
I heard
small. Yeah, go ahead.
I heard 10 as well. So 10 to 12. Okay, so we've got a ways to go, huh? So that's my from 4 to 10 or 12. Yep.
Yeah.
That's all I wanted to point out. Yes. Fred wants.
We get to a point where they're no more discovered, they're invented.
Yeah.
It's like you add more abstractions in the mathematical models, and you go deeper in the number of dimensions to the point where it doesn't make sense anymore.
Right.
It's,
Yeah.
so discovered is there's a
Yeah.
frontier there.
There's a great conversation of whether mathematics was discovered or invented. And that is one of the conversations that people like to have. And Fred has just challenged us on that. So, really good. Okay. Any other thoughts, comments? Here we go. We're about to dive into this reading. Okay. I don't mind starting the reading. I don't like to finish it usually, but I don't mind starting. Let me see. I got to get this thing out of the way. All right, here we go. And I'll make it a little bigger here. Okay. 4 dimensions. Back to the jitterbug. Fuller proposes that this fluid transition from stage to stage is best described as 4-dimensional. The vector equilibrium model displays 4-dimensional hexagonal central cross-section. Synergetics 966.04. 4-dimensionality involves an omnisymmetrical equality of radial and chordal rates of convergence and divergence. First of all, radial and chordal equivalence produces 4 distinct planes. And secondly, the jitterbug contraction operates around 4 independent axes. Let's see how this works. Triangles hold their shape, and therefore an equivalent model to the stick jitterbug described above can be built out of 8 cardboard triangles hinged together with strong tape. The advantage in this case of solid triangles is that it makes Fuller's 4-dimensional assignment easier to understand. Well, I don't understand that. 4 independent axes of rotation. Let's see if we can read and it'll disclose more. The 8 triangles operate in pairs. Diametrically opposite triangles remain aligned, rotating synchronously about a common axis as they together approach the jitterbug center at a constant rate. The separate pairs thus rotate around 4 different axes, displaying simultaneous motion in 4 distinct directions. Push straight toward the table. Don't let either triangle rotate, Bucky emphasizes the simplicity of the task. He then feigns surprise at the subsequent twisting at the equator. The entire system converges symmetrically despite the unidirectional force. He calls this behavior 4-dimensionality, referring to the 4 independent directions of rotation. Any comments on that?
You say you don't understand the model with 4 triangles, with 8
I
triangles.
don't get this whole thing about 4 independent axes of rotation.
I think The idea is to build a model for yourself with strong tape and triangles made of cardboard, and play with it until stare at it until a solution appears.
Okay. I've been screwing around with these magnets for quite a while, and I've learned a lot by playing with it. I have to admit that.
Yes. Where did you
but
get
as-
them?
Where did I get these magnets? I can actually give you a link to this. There's a
Okay.
company out of Texas.
Okay. I appreciate
Drop it in the chat there. So let me see. I'll make a note to, I'll say magnets to Fred. You don't need to drop in the chat. I got it. Cool. That has really helped. And I'd like to know where Manu has his two-dimensional thing that he is able to fold into an icosahedron. I would like to get that two-dimensional magnet thing. That was really powerful.
Steve, what about
Yes.
the jitterbug? The jitterbug, do you have to make it yourself, or is there something we can acquire?
I think Richard has a. Richard, do you have a jitterbug? Don't you have
Yeah, I have a number of them that used to be sold through BFI.
but they're not, I don't think they're available.
No, they're still. We use them as warm-up kits in one of our workshops. We actually had the.
Yeah, there it is. Fred's going crazy.
Yeah. We use that model, same colors and everything. And then we had the other Tensegrity that had the firm sort of sticks and the elastics holding it together. And we got people playing with them. And it was really funny that to begin with, they all liked the Jitterbug. They thought it was really great because it was flexible and moving around. And when they worked with the Tensegrity, it was stiffer and it was harder to move. And so they felt that it was too rigid. And then somebody in a number of sessions would say, "Oh, yeah, the rigid one is more like sort of government bureaucracy, and the other one is sort of independent sort of enterprise freedom." And then as they kept playing with them more and more, then all of a sudden they said, "Well, wait a minute, but we can't get that jitterbug to stand still." uh, and then said, actually, you need some firmness, some structure in life. And so maybe the jitterbug by himself is not sort of perfect. Um, and so they ended up being able to say we have to have both and. We have to have something where it can be kind of stiffer and secure, and other times it has to have a lot of flexibility and mobility. And but it was amazing when you put the two toys on the table with adults, and it really invited them to be in an adult kindergarten, if you want, and just play with the toys. How reluctant they were to begin with, and then they really got into it and started to feel both the playfulness of doing that and also the learning that was coming out of the experience as they realized that what they thought was perfect in the beginning then started to change their opinions in terms of some of the experiences they were having. And yeah, so it's love to see the jitterbug like that. It's yeah.
Cool.
But that's, I don't know, even with Fred having it there where we can see the top triangle pressing down towards the bottom triangle and then watch it twist into the octahedron shape and then fold down and then back up into the tetrahedron and all the way back down to the triangle.
And
You want to try to show that?
what's that?
Would you like me to try to show that?
You
Sure.
started, it looked like you were starting to show it. Please do. You guys know how to pin Fred to the If you know how to pin Fred to the screen, you can do that, and then he becomes full screen. There we go. Gee, Fred, you must do this quite often. You have an overhead camera, my
I
friend.
just installed it yesterday
Wonderful.
because I know if you start playing with things in front of your face, nobody sees anything.
Yeah. How
Okay, so
wonderful.
my Jitterbug stayed in a box for many years, so it's a little bit awkward. So now we've got the bottom triangle. We got this one. We got the bottom triangle with its head
Yeah.
moving this way. That's green, purple, and orange one. And we have the top one, which is this one here, the blue, red, and yellow one. So I'm going to move up and down. So my Jitterbug is as old as me. So if I press down, it starts rotating. It's trying to fold.
Because it's been in a box for too long, Fred.
Because it's been in a box for very long.
It's
yes.
your karma coming after you, my friend.
Yes. There you go.
There we go.
Mm.
Now, and as this goes and changes shape and it seems to change volume, think of the
Yeah,
metaphor.
of course. The volume compresses.
Yeah.
The maximum volume is when every vertex is
At
as
maximum.
distant as the other vertex as possible, as the other vertices as possible. And then when you press on it, it rotates
Mm.
and it compresses, the volume compresses. And then we get to that point, which is the
Octahedron.
Mm.
it's not an octahedron. Is that an octahedron?
That's
I
an
don't know.
Yeah.
octahedron.
If Manu was here, he would
It is
tell
an
us.
octahedron, Fred. It's one of my favorite shapes.
Okay. And
It's this
then
guy right here.
and then you can keep going, compressing it, and then it gets to the point where you have
A four-bonded triangle.
yes.
Mm.
Well, in the middle of this, you have a
Tetrahedron.
tetrahedron. If I
Wow.
So as I look at that and to remind us of the metaphor that's presented,
tetrahedron,
yeah,
and as
this,
we said last week, we have the dual of it. Unity is plural at minimum of 2. The tetrahedron appears also on the other side.
yeah,
You can reverse it.
and technically it's pulsing back and forth all the time. So, and again, coming back to the metaphor that I read at the beginning of this call, think of this as water. At one stage, water will fill a glass. When you freeze it, it turns into ice, it gets fuller. When you evaporate it and turns into vapor, it looks like the glass is empty. And that's really what's happening here is it's the same molecule, it's just changing its shape and volume.
Wow.
Yes. And the expanded one would be the vapor stage,
I would think.
vapor state. And then as you compress it, it becomes liquid, and then it becomes a solid, ice solid.
Right.
Yeah, the other thing too is that when you hold those two triangles instead of sort of the up and down axis, but hold them in a horizontal axis, much like you would hold an accordion, and then you can push the triangles toward each other, but you can
Yes.
do it in a way that they will move counterclockwise and then clockwise, and if you do it quickly, then you see the jitterbug bounce back and forth between sort of a clockwise and counterclockwise movement.
I remember doing this when it was still young, but now it's having difficulties. Yeah, you're right. It goes one way, the other way, one way, the other way, one way, the other way.
And what our grandkids liked about the Jitterbug when they had them was the versatility, and they turned them into hats.
And the
And
hats.
they had all kinds of fun creating a different kind of shape of a hat. Sometimes it looked like a helmet, sometimes it looked like just a cap. But they spent hours just fiddling around with that very model, and always coming up with, "Hey, Grandpa, did you see this cap or that that kind of helmet, etc." And some of them they had it so they could put their head in it, and some of it they sat on the top of their head. But it was very typical of what kids had to have fun with, just sticks and other kinds of artifacts that might be in their backyards or in their villages in years gone by, and didn't have all the technical sort of toys that. Yeah, that's right. Yeah. Yeah.
I took Bucky's Jitterbug video and transcribed the whole thing. And I have that in a PDF file. So as Bucky explains it and goes through all the phases and shows how it goes back and forth, I have that all scripted out so you could actually study it, because I found Bucky very hard to understand. It took me a while to listen carefully several times to find out exactly what he was saying, because the audio is so distorted.
Mm-hmm.
Bucky
I
is
will.
notoriously hard to understand.
Yeah. Yeah.
Yeah.
And I will put that Jitterbug video in the chat before we're done, or attach it to the email. By the way, this reminds me. So this week I sent out an invitation via Google, and I also sent out the invitation on a regular email. Did everybody get the Google invite, and did everybody get the email invite? Did anybody not get one of them? I know Fred did not get the Google invite. Does it
I
make
got
any difference to you guys which one I use? I'd rather
Um,
not do both.
I get the Google invite all the time, so
Yeah.
that works.
Yeah. Okay, well then I'll do both. That way everybody gets access to it. And I like the Google because it gives a history. If somebody does get the Google Calendar, they can go back and it links back, and they can go to every one, and every one of the invitations has the previous week's call on it, if there was a call the previous week. So that can be very helpful. Okay, so I have down here Jitterbug PDF. I will make sure that goes out. I'll put it in the chat, and I'll send it an email. Okay, good. Any other comments or questions? We'll continue reading.
Yeah, thank you very much, Fred, for showing us that. Yeah, thank you. Actually, taking the time to move it to the different shapes is really, really helpful.
Let me see where we
I
go.
bought that 20 years ago. It was 2026, I think. 2006, I believe, from the Fuller Institute. I don't think they sell it anymore.
Yeah, I'm checking here, and it's
They-
out of stock.
They were selling, it's out of stock. They were
Mm.
selling also let me show you. They were selling also some construction kit with some connectors, and you could connect them and make some shapes.
Yeah. And that's the Zome kit, and one of the founders of the Zome is on the regular trim tab meetings that we have every second Saturday.
Oh, I
we
just found here.
Yes,
Oh.
like you have the
It says the vector flexors back in the store, 2015, but don't know whether they have it now. Anyway, this is in the institute.
Is this for sale now?
Okay, let me take it further and see.
I think that zone thing is for sale somewhere on the web.
Oh,
I
yeah.
bought one once and I had real trouble with it.
Hmm.
Those little, each of those radial, the sticks, had different shaped ends on it, and those different shaped ends had to match the holes in the balls.
Yes.
Right.
And I had trouble with that.
You had trouble with it?
Yeah, I'm not very dexterous, I suppose.
Well, I spent half the week playing with that. I was very frustrated because I don't have enough connectors. But if you stick with it, I mean, it's a little bit frustrating in the sense that it requires playing with it a little bit before you get a sense for it. But once you got it, it's working pretty well. At least for me, it's working pretty well.
Yeah,
For
I
instance,
love the
you've
magnets.
got tetrahedron, and you've got another sort of duo. You've got the tetrahedron that we mostly see in the drawing from Bucky, and then you have another one which is centered on each face of it.
I like the magnets because the magnets just connect. I didn't have to have a special end on a stick, just a magnet works. And I think that's more like real life. Maybe. Maybe not. Maybe molecules require certain receptors. So maybe there's a lesson to be learned there.
Maybe.
Okay. Wow, Fred, I'm envious of your overhead camera. That's amazing.
You know what? That's a camera I bought in 2014 to do that exactly for the Bucky call. And then at that moment, I was not able to make it work because Skype and all that did not allow at that time to change the camera.
Yeah.
Here with Zoom, I can also have the camera use my phone camera, and then if I want to show you something outside and or move it, I can do that.
Yeah, I should try and do that. Richard, what was that red box you were holding up?
Yeah, that's the original Tensegrity toy kit that I used to work with, and it went out of business quite a few years ago, but that's where you can get the Tensegrity that you can build six tetrahedrons out of it, or you can build the full sort of icosahedron. I actually have an icosahedron hanging up in my little office.
Cool. Okay, if everybody's ready, we'll go back to the reading. Who would like to read at this point?
Well, I wonder if we can just stay on this for a minute, because I'm trying to understand why or how he goes about saying there are four different axes. Therefore, there's four dimensions. How is he working with the notion of axes as a dimension?
Especially when I look at this drawing, this graphic, where he explains there are four independent axes of rotation. I don't get it. Who sees four axes of rotation there?
Well, you can see something when you see the 8 triangles operate in 4 pairs. So that way, I mean, I can see the horizontal axis. I can see, if you want, a vertical axis, and then there must be 2 other angular axes that the whole model kind of passes through as it presses down and twists into the sort of self-organizing shapes. But I guess I'm just curious as to how is it that axes have to do with dimensionality. And when I put it back into the tetrascroll, then I can see 3 axes in the terms of the XYZ axes. And then when you change the angle from 90 to 60 and you connect it to the observer, then I can, in that sense, I can see the 4th axis. But I've now also got 6 interconnections in the model that it forms. But
this looks like the square of the cube octahedron. And obviously there's a triangle coming off of each of these planes. Maybe that's the 4 independent axes of rotation. Anybody else have a better idea?
Okay, let me try this one. I'm looking at the drawing, right? From the middle, I see eight sticks coming out, right? So that would be 4. If you're looking at it, that would be the 4 axis. Because
Right.
if we're looking at 3 dimension, right, the way we have the X, Y, Z, so this is the X. Can we see? This is the X. This is the Y, and the Z is here, right? That makes 3. So you have the X, this is the X, this
Right.
is the Y, and then you have another one Z. So that makes, you have 6 sticks coming out, right?
Okay.
So that's 3 dimensions. So I think this is where the 60 degrees come in, where the way I'm looking at it, they're all at the angles. They're all at angles, but not so clearly like this 90-degree thingy. Here, here, and here, right? So it's coming at an angle, and I do see 4 axes instead of 3 axes. Can you see that?
Yep.
But they're not 90 degrees. They're different angles.
Yeah. Cool. Any other comments? Okay. We ready to read? I suppose we're ready to read. Who would like to read?
I can go ahead and do that.
Okay.
Yeah. I have some ideas about fourness, but anyway. I'll
Well,
come
if
back
you
to
want to
them.
share your ideas of fourness, please do.
No, I mean, it's just the idea of transformation. And just going from the cube octahedron to the icosahedron to the octahedron to the tetrahedron. And that's the same thing that Fred was just showing us.
Okay.
So complex of jitterbugs. In an isotropic vector matrix, adjacent vector equilibria create octahedral cavities. To fill space, the 2 polyhedra must occur in equal numbers. Contemplating this alternating array in light of the vector equilibriums, jitterbug behavior, Fuller suspected that a complex of jitterbugs could be synchronized to twist and contract, while their octahedral counterparts simultaneously expand, twisting open into vector equilibriums. It is an extraordinarily difficult vision to conjure up in the mind's eye, and an array of synchronized twisting triangles transforming from order to chaotic inscrutability, and then back into order. But with all these places switched, vector equilibrium becomes an octahedra, octahedra becomes a vector equilibrium. The ease of confirming the jitterbugs of one of the vector equilibriums does little toward answering the question of whether a number of interconnected jitterbugs can coordinate to create this dynamic labyrinth.
Now, the next page is a little bit confusing because they have this graphic, and it has a comment on the graphic.
Hmm.
You want to read that, Joe?
Sure. Photo dash 11-1. Underneath it. Complex of jitterbugs. An array of alternating octahedra and vector equilibria is shown on the left. On the right, the display is undergoing the simultaneous transformation of all cells, such that the octahedra are opening up to become vector equilibriums, while the vector equilibriums are contracting into octahedra. The action is frozen in mid-transformation, making it possible to see the icosahedral phase. Photo courtesy of Carol.
So staring at those pictures, if we read that again, an array of alternating octahedra and vector equilibria is shown on the left. That's alternating octahedra and vector equilibria. On the right, the display is undergoing the simultaneous transformation of all cells such that octahedra are opening up to become vector equilibrium, while the vector equilibria are contracting into octahedra. This action is frozen in mid-transformation, making it possible to see the icosahedral phase. Okay. Comments, questions?
We need a video of that.
Say what?
We need a video of that to
No kidding.
visualize it.
I totally agree with you. Okay, Joe.
No, it's just interesting. Would additional vector equilibriums packed around a single one serve to lock it in place? The question is difficult to answer without actually putting.
Whoop, sorry.
That's okay. Page 192. Oh,
I clicked too many times.
quite all right.
There we go.
It to the test with the aid of a model. An awesome task. Thanks to an ingeniously designed 4-valent universal joint to accommodate the intricate twisting of adjacent triangle plates, a magnificent sculpture has emerged after considerable speculation. That's interesting. A movable complex of stainless steel and aluminum triangles hinged together effectively demonstrates that the convoluted transformation is possible. This translation from the abstract mathematical concept to the physical manifestation of the motion is both an engineering and aesthetic feat. Fuller proposes that this complex pulsating jitterbugs demonstrates the effects of force propagating through space, a tangible display of otherwise invisible energy events. Energy wave propagation. You introduce just one energy action, push or pull, into the field, and its inertia provides the reaction to your push or pull. The resultant propagates the Omni intertransformations, whose comprehensive synergetic effect in turn propagates an omnidirectional wave. In other words, the unique symmetry of the vector equilibrium combines with this newfound jitterbug property to produce a model of omnisymmetrical motion, a radiating wave of activity. Just as the IVM is a static conceptual framework describing the symmetry of space, this model illustrates the concept of dynamic eternally pulsating energy events in space, it causes the IVM to come to life. In a way, he's actually even talking about consciousness there. A model can elucidate, elucidate, I hate how I said that, but a concept without being an extract duplicate of the phenomena in question. In fact, considering the oddly mystical language that creeps into modern physicists' description of atomic and subatomic behavior, we can conclude that the invisible reality does not readily submit to large-scale reenactment with solid materials. The intention of Fuller's models, therefore, is to provide a consistent analogy, a tangible display that parallels and thereby explains invisible behavior. That's important. Dropping a stone into water discloses the planar pattern of precessional wave regeneration. The local unit energy force articulates the omnidirectional spherical expanding four-dimensional counterpart of planar water waves circular expansion. There's I'll look for it, but there was a video actually of 52 Living Ideas that we had covered.
Can someone explain pictures to me? Because
Which
that
picture?
didn't explain it.
Explain which pictures?
Up above.
This guy?
Yeah.
Here are triangles. There's an octahedron right there. Do you see the top half of the octahedron?
Yes.
And then over here, we see a bunch of squares. So these octahedron have started shifting. And when you see the squares, you see the vector equilibrium manifesting because squares are part of the vector equilibrium. I can say those words, but I'm not sure I understand any more than that. Can anybody say anything to illuminate and answer Lee's question?
Well,
You see the top, you see the pyramids here, right, Lee?
Yes.
Okay, that's the top of a cube octahedron.
Yes.
You see the square over here?
Uh-huh.
Well, if you notice, there's a square base underneath this cube octahedron,
Uh-huh.
that square base, and now it opens up. That's all I can tell you. Richard, were you about to say something?
yeah, well, I mean, it's just to me, it's a more complex sort of modeling of the jitterbug, where as you start to press down, you get that movement down that starts to twist and open up the faces, so you begin to see the square. And I don't know whether on the column it's such that you could push down and let back up, push down and let back up, and if you did, whether or not the twisting would change from counterclockwise to clockwise or vice versa. And so you get that dance if you were able to pump that diagram up and down. And so to me, I have to go back to Fred's jitterbug model to see the what happens as you press down and the twisting occurs and changes into the octahedron and then down to the tetrahedron and eventually all the way down to the triangle.
Well,
and then it bounces back up. If you just let it go, it will bounce right back up to the starting point.
I have a graphic of that.
okay.
And I think that's what we've discussed before too, that the importance of having the triangle and the squares together is that if you had all triangles, then it would be stiff. It would be, overstable if you want. But when you put triangles and squares together, then the instability, if you want, in the square helps create the motion and the movement that's necessary in order to have a dynamic sort of interaction of axes and dimensionalities.
The one on the left, if I look in the center of it, I see a square. And in A, I see squares.
Here's the square.
Uh-huh.
Yeah.
Yeah, here's the square right here.
Mhm.
And as it folds, here's the icosahedron.
Yeah.
And if you look at the other picture, you'll see a couple of these shapes. This is what he called a hinged diamond, I think he called it. What the heck did he call this in the script? As it fades around. And so there's you see, here's here's a little hinged diamond showing. So his point here is as you see these squares and it starts to fold around, you see the icosahedron start to form as the octahedron breaks down. Anybody else want to say anything?
I was going to say something about just a presentation that a lot of this but it reminded me on, but it doesn't necessarily fit right at this moment.
You said
it's
something
in-
about consciousness too, Joe.
Oh, definitely. I mean, that's all this is about. Essentially, the unfolding of life, kind of unfolding of patterns. So what you're just seeing is a set of fractals. That's it. I mean, it's really that simple. And so, and then you have complexity that's emerging from simplicity. And I mean, you see that in all throughout nature. You can think, an interesting way of thinking about it, Lee, is I mean, I'm depending on how much programming or if you're into that.
Mhm.
Look at it as a series of if-then statements.
Mhm.
So if X, then Y, and then you can see a pattern from there. So like it's nested. And that's kind of where the constant unfolding kind of occurs. So that's one way of kind of looking at it with fractals as well. So, but there's an underlying pattern that you're actually starting to be able to identify.
What do you mean by underlining?
Underlining pattern. That's a good question. There's the idea that it's basically the same motion that is reoccurring. That's the way probably to say that. So then that creates the pattern.
And I would say,
go
ahead, Joe.
No, I'm done.
Well, I would just say, if we go back to the analogy of water, ice, and vapor, they look so dramatically different, but they're actually the same molecule manifesting with different volumes.
Mm.
And so it looks different, but it's the same animal. I think I keep coming back to that metaphor because that's the one expressed at the beginning of this section.
Mhm.
Any other comments or thoughts? Okay. If we want to, we'll continue to chomp on this book. Let's see here. We were right at the bottom of that last paragraph, I think. Whoops. I've kind of lost where I am. I'm back and forth between the book. We did dropping the stone, right?
Yes.
Yeah.
Okay, good. So we're going for the next page.
That was the comment that I had. Is basically it reminded me of something that Tometry or something like that we had a presentation at 52 Living Ideas.
Oh, yeah.
Where he's talking about how to think about physics using something called field structure theory.
Yeah.
And basically it was, you know, kind of using that same type of concept as like kind of what he's like dropping the stone in the water, you know, and how it kind of creates, you know, the processional pattern. It was, you know, it's been a while. I was trying to look up the notes from it, but
Well, I remember that conversation, and I was really excited about it. But when I listened to the guy's
yeah.
presentation, it just went way over my head. I didn't get any.
Yeah, it was really, I don't think you're
I didn't get anything practical out of it. Which is not to say that it wasn't a brilliant idea.
No, I mean, it's very, I mean, yeah, it was that I think was the most complex presentation that they had.
Yeah.
But again, on this one though, the 90-degree sort of motion, I feel is fairly easy to visualize, in the sense when you drop the stone down in the kind of vertical axis way, and it hits the water, and then it starts to the 90-degree ripple effect out from the point that it hits the water. And so that's my understanding of precession, is that you have an axis kind of motion that creates motion in a direction that's perpendicular to the original axis. And that's how I used it in helping disciplines, the idea of the up and down axis between the helper and the person being helped. And as they get into sort of like a jitterbug motion of back and forth reciprocal action, then it creates motion that is perpendicular to that axis and goes this way, which is another way of representing it goes from the original problem, if you want, through a process to a solution. But it happens because of the up and down axis movement creates motion 90 degrees to that axis.
Okay.
And the up and down in a human relationship way has to have both parties interacting with each other, which comes back to that formula of n squared minus n equals r over 2, but because if the reciprocal motion, you have to take the denominator out, and you get just n squared minus 1 minus n equals the reciprocal number of things that are going back and forth.
That is profound. And let me share another thing that came to me as I was hearing this. Is that the stone itself that's being dropped into the pond? It's a torus of energy. It's a spinning torus of energy that looks like ice. It looks like an ice cube. And yet it's a spinning torus of energy. And as it goes down through the atmosphere, it's actually pulsing through the atmosphere as it goes, not on a two-dimensional plane, but on a three-dimensional pulse. And when that torus of energy hits the water, we see the two-dimensional or the planar reaction in terms of ripple, but it's actually spherical. And it's affecting the air as much as it's affecting the water. We just don't see it.
Yeah.
So it's exhausting to watch a stone drop into a pond. Okay. Are we ready to read some more, or is there more conversation?
Some experiments, I don't know if I can find a video, done on the Chinese space station about slow motion, things dropping into some liquid. And there was a picture by picture, frame by frame comparison what happens with gravity, that is back on Earth, and what happens in microgravity in orbit.
Ooh.
And what happened was that when you drop an ice cube in water, for instance, on Earth with gravity, you have a ripple like this, but you also have a crown
Yeah.
going up. Yeah, I think you've all seen that. And you've got a sort of spike in the middle going up also.
Right.
What happened from memory in microgravity is that you only have the ripple outward.
Ah.
Not have a crown, and you do not have a spike in the middle. And
Ooh.
it's really amazing. And I think they can't explain it yet.
I just
They
saw
do
a short. Go
they
ahead.
do a lot of I think it's live or maybe it's recording videos from the Chinese taikonauts in the Chinese space station directly to schools. And they have experiments and they do that with schools. And here everybody wants to be a taikonaut now. That's absolutely amazing what they're doing. Yeah. There has to be a video on the web for that. I'll look at it later.
It would be great if you could find it. I'm recalling a short that actually showed what happens in multidimensional in terms of when that ice cube or whatever it is drops into the water and how it forms that dome that you talked about. And they actually sliced it and interceded to show where the energy is going when something affects it and how beautiful it is. Most people don't see that dome, and there's a drop that comes up as a reaction to the drop going down. It goes up as Fred says, and I didn't know this, in microspace there's no drop up. There's no opposite reaction. I'll do what I can to find that link and share it as we go.
We've got to be careful with the vocab we use. Maybe I used it too. It's not up, it's out.
Out. I've had this conversation, Fred, and I've decided that in terms of a local conversation, up and down works. I can't say go out the ladder, and I can't say go in the ladder. I have to say go up or down the ladder. So in local discussions, we don't have to be pure Buckyist. That's my self-defense.
No, I don't have any strong feeling about that. I just like to remind it so that we just brings it to our consciousness, even we still use it for.
And I'm so glad you did, because I think in this example, out is actually appropriate. When the cube drops in, it hits the water and the droplet comes out. I think that is actually better terminology.
Yeah, it's radiates based on gravity.
Okay, I have something to say about this, yeah, because after going down this path of the water dropping, and it's actually 3D radiating outwards, right? Because I think the idea of that stone dropping in the water for us to see the concentric circles as it radiates out is just an analogy of what it looks like. Because I think when things happen, you don't have it dropping anywhere, right? So it's like at the core of it, which will actually explain the one in space, because when anything happens, it happens here, it doesn't drop, right? It happens here. So everything is radiating out of it at three, like it's a sphere. It's like concentric spheres, radiating outwards. So that actually would make more sense for something happening than something dropping into the water, right? I think the water is for us to see the circles. That's it. But the reality is it's that in the middle, the thing happens, radiates out like that.
That's a very good point. And that may explain why the spike does not appear. Yeah.
Sorry, Fred.
I say that's a very good point you're making. That's a very excellent point.
For me, that's better, because every time we talk about precession, right? I love the idea of precession, from something in the middle, and then it radiates outwards. And actually, this is what is more critical. That like you really need to see all the way out here, because you cannot imagine the impact as it radiates out. Most people cannot imagine, and so that's why they mess up so badly, right? Anyway, or create such amazing stuff. But that is my biggest realizations today, right there.
Well, hey, the other thing too in that other dynamic, if you're thinking of the well, for me, it's somebody who's saying that they need help, and so they drop that, in the lap of the helper. And in sort of a typical way, the expert, specialized way, then the helper takes that and assumes that they respond with their expertise instead of bouncing it back, if you want, from their perspective, and to get that bouncing back and forth. And then when it creates the ripple at that 90 degrees, it's much like what Manu often talks about, that the ripple can go one way, which you might say is positive, and it can go the other way, which is negative. And that's one of the things that in the human relationship context, there's not enough sensitivity to that ripple effect being able to go both positive or negative, which then brings us back into the chaos theory, nonlinear side of things, where a little change, a little adjustment can create a big reaction or a big solution, but it could be a positive solution, it could be a negative solution. And I think that's some of what those in the healing professions, from a scientific, if you want, point of view, aren't sensitive enough to. They really think that once they get the drop in their bucket, they can respond with their expertise, and that should fix everything. And sometimes they will not appreciate how much of the reciprocity that has to go back and forth to create that ripple to go out in the right sort of direction, if you want.
And boy, is that a
Well,
profound conversation, because you're so right. Helpers sometimes don't help because they think they're helping.
mhm,
When they're not listening, they're not allowing feedback. They're not being sensitive to all of the vibrations.
mhm,
Yeah, good point. In fact, when you sent me an email, Richard, about your SAO thing, I have a comment on that that's brewing in the back. I've got it on a paper over here to talk to you about, because you brought up the word helper, and I like the word assister.
mhm,
And I know you agree with me on this just from the conversation that you talked about. There's a point where a helper is not helping. And if I'm assisting someone walk, it's different than helping them walk. And if I don't know the difference, I need to learn the difference. So that's a profound conversation. I like it. Any other thoughts or comments? I'm really frustrated. I've got to come up with a better way to categorize this stuff, because when I saw that water thing, it was not only beautiful, it was just majorly significant for me. And the fact that I'm not finding it right off, I'm going to do a better job. Manu, you're right on time. I'm never late. I'm always on time for my experience, and here you are on time for your experience. How are you feeling? And what do you expect today?
Apologetic. Sorry, I slept late,
Good for
and
you.
Yeah,
yeah,
I'm
I didn't
jealous.
want to interrupt my sleeping.
Good
So
for you.
yeah, so I'm just happy to be here and then to listen, and then see how I can board the train.
Cool. Really good. All right. So are we clear on comments at this point? Should we go back to our reading? Okay, we have a couple more minutes, I think we can read. We're on page let's see, where the heck are we? We're on page 193 at the top of the page. Joe, you were reading. Do you want to continue reading, Joe?
Absolutely, sure, no problem. The expanding concentric waves made by a stone dropped in a lake are directly visible on the water's surface. It is therefore easy to picture the image of a wave propagating across a plane. It is more difficult to visualize a corresponding situation in space, which is precisely the territory Fuller is set out to conquer. He strove to clarify invisible aspects of reality through models that can be seen and felt. The complex of jitterbugs makes the concept of expanding spherical wave of energy visible. That's profound in and of itself, right there. By showing the physical, he's kind of demonstrating how the nature of reality and how these shapes actually fold into one another. Whatever the analogous events in the universe, the model is intricate and phenomenal. Fuller's argument is that nature depends upon such dynamic orderly coordination. The complex of jitterbugs demonstrates a complicated but organized operation. And if nature permits this transformation of her omni-symmetrical framework, she might use the same trick elsewhere. At the moment, jitterbugs therefore merely hint at possibilities. It is worth reflecting on the extraordinary intuition required to have discovered this subtle and magnificent geometric phenomenon.
Any comments or questions there? Okay.
Yes, that's what Anne was saying. It's a three-dimensional in its expansion. Thank you, Anne.
Welcome.
Cool. Want to continue?
Sure. Other dynamic models, topology and phase. Physical universe differentiates into three categories: liquid, crystalline, and gaseous phases. These distinct states of matter arise as a result of changing temperature or pressure, which induce different types of bonds. Fuller proposes a simple geometric analogy to make these invisible changes easy to comprehend. Appropriately, the model is completed with an exhaustive enumeration of the waves in which two tetrahedra can be connected to each other. That's important. The three arrangements of the minimum conceptual system model the three phases of physical matter. First two tetrahedra are triple bonded, sharing one face between them, figure 11-8a, because the relative positions of the two tetrahedra are completely fixed. The arrangement qualifies as a stable set of relationships and represents a crystalline structure. The closest packing triple bonded fixed end arrangement corresponds with rigid structure molecular compounds. Once again, the intention is not to create a large-scale duplicate of a particular solid compound, but rather to display the different, I keep having a fly come by, characteristics of each chemical phase. The model is a kind of visual shorthand. One of the three bonds is now released, leaving a double bond between two tetrahedra. The shared edge acts like a hinge. The tetrahedral pair can swing back and forth, but they cannot be moved closer together or farther apart. The configuration is thus non-comprehensible. One of the distinguishing characteristics of liquids, it blends any way you desire, malleable just like liquid, but the double bond persists. The medium packed condition of a double bonded binged arrangement is still flexible, but summed totally as an aggregate, all space filling complex is non-comprehensible, as are liquids.
These are the pictures that Joe was talking about as he read. Bonding models of phases of matter.
It's also showing the relationship between two tetrahedra.
Right. Okay, we can finish this chapter.
Finally, we break another of the bonds. Single bonded tetrahedra are joined by a vertex, and their behavior is analogous to that of a gas. The vertex bond acts as a universal joint. The two halves can swing freely with respect to each other, moving together and apart without disrupting the type of bond. The arrangement is comprehensible, expandable, and completely flexible. Short of disassociation. Or no, yeah. Perpetual connectedness indicates that both the tetrahedra continue to participate in the same substance. They exhibit a consistent relationship, but lack structural definition. Tetrahedra linked together entirely by a single bonded universal jointing use lots of space, which is the openmost condition, I'm assuming, yeah, of flexibility and
Mutability.
Yeah, mutability. Sorry, I was thinking malleability for a moment. Characterizing the behavior of gases. The analogy is complete. All the while, Bucky holds the simple structures in his hands and explains the different basic properties, solids, liquids, and gases. With any luck, a small child is present, forcing him to keep his discourse simple.
That's a joke.
How can the same type of molecule produce such radically different substances? Bucky offers a tangible explanation through geometry. This model is perhaps useful as a mnemonic. Sorry, yeah, started pronouncing it in their device. An easy way to remember the chemistry lesson by relating the different characteristics to their analogous stage of the model, rather than as a true demonstration of phase changes in a substance. It is worth noting that this model of interconnected tetrahedra is more appropriate and, in fact, quite accurate in connection with the bonding of carbon atoms within molecules. In conclusion, it is unfortunate that this and other polyhedral characteristics and relationships are generally overlooked in educational curricula. Fuller developed many dynamic models, and readers who go on to further study will find a variety of examples in synergetics. The transformations discussed in this chapter set the stage to explore other examples. Appropriate parallels in nature may well arise from such efforts.
Okay, we've just completed chapter 11. Any thoughts jumbling up here through this?
I've got.
Okay, go on.
Sorry, I think I've got a major one for what I at the beginning of the call. I said, at the end of the chapter, each chapter, there's something usually big that comes up, and I just saw it as well. We because of that three-dimensional thingy, right? We were talking about the circles, the water dropping and the circles radiating out, and then we start talking about 3 dimensions. Because early part when we talked about the jitterbug and Fred, you were showing how the thing moves. Actually, there's one thing that came out from it. When you moved it down, I could see clearly the diagram in 11 dash, let me see. -1 at the beginning of this chapter, right? But more importantly is this, I started thinking about jitterbugs, not jitterbug, right? So we're looking at how one jitterbug works. Well, my God, I'm like, that means we're looking at jitterbugs everywhere, right? And because it's moving all the time, and then, okay, I'm going to link it now to the the event that happens, right? We talk about events. So with the event, then everything radiates outwards. Now, if you're talking about one event and everything radiating outwards, then we got to look at many other millions of events happening all over, and they're all radiating outwards, right? So then I'm linking it now to Wednesday call, which is the interference patterns, pattern interference, right? With waves. And we're just looking at one small thing. But when you look at everything coming together, it's massive. In all the discussions we've had for Bucky in 3.5 years, we've been looking at that one thing, right? The jitterbug and so on. And suddenly, plus the cosmometry, and suddenly we're looking at these things are all intercepting, they're also interfering. And so what does that even look like? You know, I mean, the world as it is what it looks like, but I'm just trying to imagine it happening scientifically, and it just blows my mind. Okay, so I'm at the point at the end of the chapter, so I'm going to toss something else. I said I was going to toss the music thing with my hits, right? Which I did that day. So coming this Monday, we're having a bigger meeting with the rest of the leaders. So I'm going to toss this in as well with my science people besides the music. Okay, so let me see what comes out with that as well. Yeah, I'm complete with that one. I think that's mainly my takeaway. Yeah.
Well, let's hang on for takeaways.
Yeah.
I wanted to go ahead. Did you want to say something there?
Me?
No,
Well, I mean, go ahead. We've been talking about this water, and Fred brought up gravity and how in microgravity things react differently. And something that's really of interest to me is it might just do well for us to watch an object fall in the water and notice that, and it's not only radiating out, it's radiating out and in simultaneously.
Yep.
And often I forget the fact that it's radiating in, but here's a rock going into water slow-mo. So we'll get the whole thing here. So it's going out and it's coming back in. Whoa. And it continues to pulse in both directions. Plus, look at all these little drops that are occurring around the edges. I don't know. It's a powerful metaphor. So, woo. Go ahead, Manu. Share.
Okay. Right. I put 3 things in the chat box. Okay. Did you realize what she says, what she was, connecting bonding and space filling? That gases is a set of bowties that touch at points. And that is the most expandable state of universe. Did you get that?
Yeah, we saw a diagram of it.
I saw a diagram before of gases as a set of bowties that touch at points. So that was that she saw she showed something like that before.
Right there.
Show me.
Bow ties touching at points.
No, what I'm saying is that she sees that she puts at sea is one bow tie.
Right.
That is one bow tie. But the set of bow ties that touch vertex to vertex is the most expandable state of universe. Do you see the concept?
think so.
Second point that I put here, let me go, is the tri-concept of finiteness, volume, and density is a triangle. Because it is finite, it is expanded, and when they expand because of duality, gases at the minimum show in two atoms, always linked. The two-atom concept is a consequence of the duality principle. No gas shows as one atom. Gases, hydrogen, always show H2. Is one sphere of hydrogen linked to another. And they are always like that. They combine always at the element level that way. Now, I have a question, and that is the case of osmosis. Where does it fit in this model? How does it happen? And I invite Fred to help us here. I've been quizzical about it.
You've been quizzical about it?
Yeah. How does it happen? Osmosis.
Osmosis happened at the boundary.
Yeah, but what happened? How do you fit in the model, in the general model?
The finiteness, volume, and density?
Or whatever that they are talking about, the bonding, for example. How do you fit osmosis with bonding? Because bonding is supposed to define the whole universe.
Okay, yeah, but
everything, energy is everywhere. Energy flows, so bonding is everywhere. Bonding is, yes.
Osmosis is a flow. So when you say energy flows, it's close to osmosis. Osmosis, if you put salt in water, the water is a solvent, and the salt is dissolved in the water. So osmosis is a movement of the water through a membrane, for instance, through a boundary, through a membrane. So how does it fit in? It fits in without bonds, because there's no bonds between the salt and the water. They just happen to be mixed together. What flows is the water. Filtering would be the physical effect of removing solid particles and let the solvent go through. But osmosis is just the solvent going through. What's in solution stays on one side of the membrane, and the solvent goes through.
Believe it that at a more general level, could live with that is the effect of multi-universes?
I have no idea.
Because if universe is finite, it has a boundary.
Yes, but nothing can be out of universe.
Yes, if it were just finite like that, it would lose nothing. It would gain nothing. So
it would
maybe ultimately
it would lose nothing, but it would gain the constant accumulation of special case experiences. The metaphysical level.
But that is local compression and expansion. That's tensegrity. That's all it does.
Yes, but that's
as a consequence of finiteness. But if you have now one finite and the other like that, you know, like universal bow tie, what happened? Maybe here at the friction of the two boundaries, there's osmosis. Maybe. It's wild, but
Your assumption is that there's several universes.
I'm saying because of special case that osmosis exists, that osmosis that exists in our system
Yeah, it can only happen
might be a fractal of something that is more universal.
maybe, but it only happens in a system because only in systems there can be in and out and movement through the boundary. But universe is not a system. Universe is a scenario.
Yeah, but scenario just higher, higher, higher. Say I'm crazy. I've seen scenarios.
Okay.
And that
Okay.
there, what we
understand.
have here instead of osmosis.
I understand. You're way ahead of all of us and way ahead of Bucky also, because Bucky only envisaged one universe. And
no, because when you take this that she's presented, she's only presented 3 bonding cases. She didn't present the final fusion. Your famous everything becomes iron. Iron consolidated, nothing, no life. What is the dual of that? That's finality. She did not, when you collapse the final tetrahedron, double tetrahedron in a diamond, she did not put that here. In this 3 bonding example that she showed. Now, if that exists and we saw it, and the Jitterbugs actually collapses into that of 4 bonded tetrahedron, there must be a dual. You must say a dual is itself, but is that dual in the form of osmosis? It does this, collapses, and then reopens, passing through universe, that boundary. Now the micro boundary or the macro boundary, I don't know, but just like wild ideas.
okay, thank you.
It's a great question, and we're moving now towards our takeaways. So if you want to take a second and gather some thoughts, anybody ready to share their takeaway? If you know your first, raise your hand. Richard, go right ahead.
Just to build off of what Manu was just saying, if we look at what is said in the text about the 3 categories, the crystal, the liquid, and the gas, then the question back would be, what would the other categories, what kind of name would be given to the other categories in that context? Like, in other words, what's missing? But what I want to share is what I've tried to do with these bonding sort of categories, again, in a human relations way. And one is the crystalline, when you bring the base to base. To me, it's a little bit like, again, this notion of somebody comes to the expert with a problem, describes the problem, the expert locks on and gives them the answer, the fix. When you have a double bond, a hinge, there's a little bit more flexibility. There's a little bit more listening and hearing, but there's still kind of an attachment that locks you into somebody else's sphere or somebody else's space. And if I have the gaseous bond, the vertex to vertex, that to me is the most volatile one, but it's the most flexible one. And it's the ideal one in terms of 2 people working back and forth from one vertex to the other vertex and allowing the back and forthness that can be highly sensitive and it can be highly explosive. And but it can also be highly productive. in terms of what both people take away from it. The idea of the person who was being helped takes away an answer, if you want, that they couldn't figure out on their own. And so they're grateful for that. What the helper does, or the assister does, they take away something that they wanted to achieve that they couldn't do by themselves, and that is to be a good helper, a good assister. And you can't be a good assister if you don't have someone to assist. And so I design my models off of the single bonding, the vertex to vertex, and try to help people understand that when you're working that kind of model, you have to be super sensitive of all the little things that you might do that could trigger the big change because you smiled at me at the right time one day. And you get that nonlinear sort of wow, aha. Or they can come back to you and say, you ruined my life that day because you rolled your eyes at something I said. And again, the proportional cause and effect person will deny that. They'll say, no, I couldn't have caused that to you. In the same way, they'll deny the appreciation that you saved my life. Because they think it's got to be proportional in cause and effect. So it's really an interesting way for me to teach the importance of the nonlinear and the linear working together in a way that we often don't include. We often just use the proportional cause and effect, the garbage in, garbage out kind of idea. Or the idea that if you work hard, you'll get a good outcome. And most of us know that sometimes you can work your butt off and you don't get what you thought you should get out of the experience. So I really appreciated this particular part of it, as it helps me reinforce why I tried to work with these categories in the way that I have in these assisting relationships. So thank you. And Anne, what's your feeling right now and your takeaway?
Okay, first I'm very grateful, absolutely grateful. One is when you wanted to connect your ex-student with me in KL. Yes, we are about 2 hours to 3 hours flight distance. That's how far we are away from each other. So yeah, but anyway, thank you so much for wanting to do that. The other one is Steve. I cannot say how grateful I am every week for you to hold this meeting together, holding all of us together, and how you put together our invites. Everything is there, from links to the key things. Even if the links are not from you, from any one of us, you're adding all that in. So I'm absolutely grateful for that. Thank you so much, and of course for everyone here. Yeah, for us to go through and get the things that we wish to get, and to be able to see what we can do to give back. Yeah. So
attention to Latin America.
So Joe, how do you feel, and what is your takeaway today?
I feel pretty good, actually. I mean, it's one of the things that you were talking about that actually really kind of resonated with me, and I was thinking in terms of how to think of events. And then if you look at events as like you have an input and then you have an output, and essentially what the function is that it essentially that is creating that input and output. And the reason why I thought about that is essentially how there is a continuous unfolding of events, and how that relates to essentially the jitterbug. And if we look at it from the idea that, the idea of the cube octahedron, the icosahedron, the octahedron, or the tetrahedron, these are things that actually fold into one another and they're linked to one another. And understanding that and understanding those patterns, essentially helps us, understand the relationships between objects, and that could be, us as well. So, from that perspective, you can kind of start to see where Fuller's ideas are, that they come into the idea of consciousness, is that we're not something that's a fixed entity. And so that there's this constant unfolding. That's where essentially there's we see kind of complexity kind of emerging from there. So, so thinking about that process in general, I mean, it's a very basic process, but having a, kind of an understanding of that process is important to be able to articulate, because when I was, kind of going through a space-time model, that a very simple one, that all these elements were absolutely essential to know. And so that by going through it and looking at it through Fuller's perspective, it's kind of given me kind of a new angle, if you will, to kind of to understand the model, that another model that I was looking at. So, from that, it's the more we go over the different models that we use and having an understanding of these patterns, actually, for me, I mean, I'm finding them extremely helpful. There was something else. I mean, it was, I won't go into it, but it had to do with essentially what we were talking about with solid, liquids, and gases. But I'll come back to it maybe next week. That was something else that that I actually wanted to touch upon. But anyway, I think that this, if you kind of understand this model, you can start to understand what an event is, what an object is, what it means for it to change, the input and the output. And then you start to understand, as well as the relationships between the physical objects that, or the physical models that Bucky has put together. And that's what actually Amy had said earlier in the chapter. So I'd say that that's my takeaway for this evening. Brad, how do you feel and be taken away from today?
Thank you, Joe. I'm feeling so empowered and excited and joyful about touching base with all these concepts, notions, stuff that have been on the back burner of my mind for so many years, and I'm very glad to bring them back up to front. That's how I feel. And my takeaway is Anne's aha at the end of the chapter. This is so, how to say, so amazing to see the light turned on and how you express it. And you mentioned that, I think last time, you said you had this light turn on, this aha moment with precession, and that you still had not gotten it for unities plural and at a minimum 2. And I'm really looking forward for the time this light is going to turn on for unity. That's so that's my takeaway today. Lee, thank you. And what is your take? How do you feel, and what is your takeaway for today? You need to turn on your mic. You're muted. You need to turn on your microphone. Lee, you're muted. You need to turn on your microphone.
There, I got it. Thank you. I feel joy because I had a situation that came about. But first, I want to reiterate what Fred had said about the wave of the water going out and touching. And of course, Steve showing the droplets coming from the rock falling into the water and causing more waves that worked with the larger wave. And if you think about the wave that comes from an earthquake, such as in Japan recently, and how it came all the way to the east to us over here in California, it was smaller than what we expected, but it could have created a massive amount of turmoil. And this brings me back to something that happened to me a couple of days ago. I had my son helping me put up bookshelves. He had to make them from Walmart. And I had mentioned something about his oldest daughter, who is 26 years old. And quite a while ago, I had mentioned to her, well, you're much bigger now. And I never knew that she took offense to what I had said. Much bigger, because she is almost as tall as her 6'4" father. And I meant it as it was going to be phenomenal to have that tall height in a female. And she took it in width and heaviness instead of what I meant. And so now, with that ripple going still through her over and over and over again, I need to go and correct that ripple and say, I believe we had a misunderstanding. And that would help her to understand that I wasn't meaning anything bad about her weight or her width, but her beauty in her height. She's a beautiful girl. So think about that in perspective with your jitterbugging with individuals. Jitterbugging can be misinterpreted, and we need to correct it if it happens. Now, Manu, did you have your turn already? How do you feel? And what do you take out of tonight, the little amount that you got?
Yeah, really good to be on board the train. I would like to ride it further, but I'm the one that was late, so I'll have to on board at some point with you guys. No, to off board at some point with you. But really what I take away here is the importance of bonding, because in bulky stuff, it seemed to like drop. And Kelly used to really insist on it, and bonding. And then now I was thinking about one thing that we study with Susan, which is the exclusive zone of water. That is the fourth phase of water. And the definition of it, I was looking at it, just hold on 1 second, is, it says that the fourth phase is water absorb infrared energy and form a crystalline structure that is dispersed and form a barrier. What is the link between that and boundary? And how does it apply at the universal scale? Is the question I was pondering here. And the other concept that I take away is what I wrote there, in that the most expanded phase of universe is that of gases linking vertex to vertex. And the notion of link, vertex to vertex, bring to us the reality of duality. Nothing can exist on its own. There's always at minimum two. And when they explain gases at elementary level at school, they say H2. But why H2? Why H2? Is another way of showing that it is always two. And that is the application of the principle of duality. And the third thing is this concept of bow ties, because the bow ties already embodies the reality of two, touching vertex to vertex, all filling universe. And the question to everybody, I haven't yet got a convincing answer, is what is the pair of what I used to call the final state of a black hole, where everything, we know that it radiates, but what is that radiation? Because when you reach the black hole level, you are coming to it gravitationally, sucking in, you have to go out somewhere. So it comes convex. So it comes out convex. So how does it correspond? Becky showed with Jitterbugs folding the 4 tetrahedra edges, packing the 16 total, packing into a tetrahedron. How does it unfold? That's the question. And my intuition is, maybe is this plasma stuff. And that's some forces I would say some forces. Some forces causes the spontaneous flow through of energy from a close side to another side. Therefore, maybe there are other universes. So that's my takeaway. Otherwise, I'm grateful, as usual, for all the contributions. I wasn't there, but at least I think that I had one idea towards the end. Who's left? Is it Steve? And where is he? Oh, I can't see. Hi, Steve. How do you feel? What do you take away?
I'm real excited about tonight. It's been a good conversation. We took it real slow. At times I felt like I was going really slow, but my brain was going 90 miles an hour. And I think everybody else was thinking on this too. I'm coming back to, at the beginning of this section, where Amy Edmondson talks about the fact that in physics, instead of that, if I'd have learned more about gases, instead of focusing on other kinds of geometry, or in addition to focusing on that geometry, because I had a lot of fun in my geometry classes. I invented a lot of good stuff. I should have learned, I could have learned more about gases and how they work. And even at that, I think Bucky's idea of the bow tie, I mean, I stuck a graphic in there about osmosis in relationship to, I think it was Manu's comment about osmosis' question. I stuck a graphic in there, but it doesn't talk about, it doesn't talk about energy. It talks about osmosis in terms of cell membrane interaction and mitochondria and things like that. But it doesn't approach this energetic form of view. So that's interesting to me. I'll tell you what, I've made a pledge tonight that whenever I talk about throwing a rock in water, I'm never going to use a rock anymore. I'm going to use an ice cube, because then I can always talk about the fact that this is a form of water dropping into water, and it's creating more, different reactions to this energy. So I'm going to use ice cubes from now on. And I'm going to also take to Fred's caution that when that ice cube drops down into the water and the reaction is something comes out of that, I'm not going to say it's coming up. I'm going to say it's coming out. So I'm going to use ice cube and say out. And I think if I can handle those two things, I'm going to be more consistent with reality in what I'm doing. So, yeah. And Fred, I'll get I think I just sent to Anne the magnet thing. I think, Anne, you got the link to how to buy the magnets, right? Didn't I send that to you in the last month or so?
Yes.
Yeah, I did. Well, I'm going to find that email and I'll send it to Fred too as well, so he can get his magnets. If there's anything else I can do, let me know. Manu, I'm so glad you made the train. It's just like you came on board just fine. And your questions boggle my mind every time. All right, looking forward to next week. I may have a conflict, but I'll keep Joe posted. Joe, if I'll keep you posted, and maybe somebody can help out. I'll see how it goes. So, any other comments or questions before we go, Fred?
Stevie, you have a minute? After
Yes.
everybody's gone, I would like to chat with you for 2-3 minutes.
Okay, cool. I'll
That's
hang
okay.
in here. Any other
Okay.
comments or questions before we go? Wonderful. And Lee, you've learned how to turn on your microphone. It's really good. I love it. We're progressing every day. We're all growing. See you all soon. Bye-bye, everybody.
Take care, everybody.
Bye-bye. I'm hanging on, Fred. Anytime you're ready. I'm going to find that button. There we go. There she goes. Bam.
All right, thanks.
Thank you.
I'm getting some echoes here. You do some mentoring?
I have done mentoring in the past. I used to do real estate consulting. And
Okay, so that was real estate mentoring.
yeah, it was transaction engineering, 401ks, IRAs, self-investing,
Okay.
and stuff like that. But I'm writing this book now on extreme mindfulness.
Yes.
And so I've got a whole bunch of efficiency in how to, instead of management by objective, management by intuition, maybe. And I might start coaching that direction. Go ahead.
Okay. I'm not sure exactly what I'm looking for, but I'm looking for bouncing balls. That's somebody that can throw them back with intent and with insights about personal stuff, my grieving, where do I go next? Should I questions like if I'm not living in China, where should I go? And these sort of things. And because I'm here, I don't have family here, and I don't have many people I can bounce balls with. So I would like
Mhm.
to do this with you if that's something you feel like doing. And of course, I can compensate you for your trouble and your time.
Whoa. Well,
want.
I would be honored. I will say, I'm amazed that you picked up on this, but just as an aside, or maybe not as an aside, maybe something you picked up on. 25, 30 years ago, I actually became certified. I completed education to be certified as a clinical hypnotherapist. I also took a thing called Silva mind control back in the 70s. Became aware of self-hypnosis and just states of mind and consciousness.
Yeah,
And as
you
part
mentioned
of,
that the other day.
oh, did I?
You
And
mentioned
so,
it, yes.
and the idea of how do I look at life, I'd be delighted to bounce some balls with you. And if you feel like that you want to make a donation, I'd be happy to accept the donation. But let's bounce some balls first and make sure it creates some value for you.
Okay, thank you. Should we set up a time
Yeah,
for the
I
conference? Not,
if
not
it's
right
worth
now.
doing, it's worth setting a time.
Yes. Okay. So can you do this now, or is that something you want to look into?
It's like 11:15 my time Saturday night. And so I would probably prefer to do it at a different time.
Yeah, sure. Now is not. I know I'm hungry. I need to go
Okay,
eat.
good, good. When would be a good time though? I'm all for, if it's worth doing, let's put it on a calendar.
What's a good time?
Usually, any afternoon or evening after
Usually
1 o'clock.
weekdays would be in my evening,
Okay,
so that would be your morning. Is that
okay, but like, what time is 1 o'clock p.m. my time for you? Right now it's 11 o'clock my time.
now is 1:17, so
Okay,
14 hours fast.
so if we did something like at 5 p.m. my time, which is 6 hours ago, is that about when you'd want to start, or when would be good for
Oh,
you?
that would be morning my time.
Yeah,
But
you
I'd rather.
do afternoons?
Well, it depends. I have somebody here every morning,
Okay,
and this is not something I would like. I mean, I'm more comfortable talking about personal things when nobody's here.
absolutely correct.
Even she doesn't understand English. It's just more convenient for me. Saturday, are you available on Saturdays in your morning?
Saturdays are good. Today was Saturday. We'd wait a week and we could do something on Saturday afternoon. I'm kind of looking at my world clock and seeing
So
where
that would be 9 o'clock morning on Saturdays. 9 o'clock morning my time. So that would be 7 o'clock morning. Is that
I'm good in the afternoon, my time. So
No, it
like,
would be 7 o'clock evening your time.
okay, good. I could, let me see, on Saturday at 7 p.m. I have usually an appointment about then. How could you
Okay.
do it a couple of hours earlier or an hour earlier even?
No,
Okay,
because then I have to take the dogs out.
all right.
It's a dog's time between 7:30 and 8:30. Later?
Well, on Saturday we do this call. So I start something up at 7, then I drop into this call at 9. What about Sunday? What about tomorrow?
Oh, no, Friday. Sorry, that would be your Friday night.
Okay, my Friday at 7, that may work.
Okay. Okay. Well, look into it and we can confirm that there's nothing urgent. It can be this week or it can be the week after. And then we can decide later on how this
Okay.
goes.
As I'm looking at next Friday, I may have a conflict, so it'll be the next Friday or the Friday after that. But
Okay.
I'm gonna put you down for 7 p.m. my time on Friday.
Forget next week. Next week I'm not available on
Oh, okay,
Saturday.
good. That's good for
So
me.
the week after.
All right, well, hang on then. Let me put this thing into a phase here that allows me to think about it. Okay, now I'm looking at month calendar. I'm looking at today the 6th, so you're talking about the 20th. That's
I'm
Saturday.
talking about
That's Saturday. So Friday the 19th.
yeah, Saturday 20th for me.
Yeah, so Friday the 19th at 7 p.m. my time. I've got it down. Now, the thing that I like about a Google Calendar is it does all these time conversions. I don't have to worry about it. But as long as we're clear, I'm at 7 p.m. Friday, the 19th of September.
What time you start your call? It's 9 a.m. It's 9 p.m. you start your call, today's call.
Yeah.
9. Okay, that's good. That's good. That's 9 a.m. my time.
Are you saying then, so 7 p.m. my time is 9 a.m. your time? Is that what you're saying?
The next day, yes.
All right, good. I'm with that. And I've got you down for the 19th.
Yes.
Good.
All right. Thank you very much.
Well, thank you. I'd be honored, and we'll see what
I'm-
happens. And I'm at least a good listener.
I've
And
been
I take really good notes.
okay. Thank you. I've been calling you Stevie. Is that okay?
Steve is good.
Okay. Good.
That's what my mother calls me. My mother calls me Steve. So
Yeah, but
No.
I've said Stevie. Stevie is okay too.
Stevie, my stage name is Stevie T.
Okay.
So I prefer Steve
Steve. Okay.
on a normal thing. Thank you, Fred.
Okay, Steve.
If you call me Stevie, I might call you Freddie. So let's stay away from Stevie.
Okay. Kelly used to call me Freddie. I hated
Did
it.
he really? Yeah. Kelly was good at he knew exactly what buttons to push. That guy was a good button pusher. Okay, sir.
All right. Thank you very much. You have a
Hope
good
to
you have a good evening. Talk to
Thank
you
you.
in 2 weeks. Bye bye.
Bye-bye.